In this tutorial, we'll make the piston rod cap, Gudgeon Pin, piston, and we'll finish it off with a motion study. Welcome to the Learn It channel. Let's make the piston assembly. So the first thing we're going to do is take a look at our drawing package. For our piston assembly, the exploded view, we have a parts list, and that gives us an idea of how to proceed within Fusion. As you can see, this is a sub-assembly within our V8 engine assembly. In our parts list, we have the piston rod cap, screws, piston pin, and pistons. So let's proceed with making a sub-assembly. We do that by clicking on our top level component, new component, and let's call this our piston assembly. Within the piston assembly, we can go right ahead and start creating each of our components, but I'd like to teach you a new skill within Fusion, and that's creating what's called a root level or a master sketch. So let's go right into our piston assembly. We're going to go right click and isolate. And what this root level or master sketch does is it creates a sketch that we can use to create more than one component. And because several components are going to be based off of this one sketch, we're going to put it again in what's called a master or root level sketch. And so that just means that with our component right here, piston assembly, again, this is just a single component right now, but it's going to turn into a sub-assembly. And we're going to create our sketch right away. So let's go ahead and do that. Create it on our XZ construction plane. And here, basically what we're going to do is we're going to sketch both the piston rod cap, and the piston pin or the gudgeon pin all in one sketch, and then create the individual components from that single sketch. So let's go right into it. Again, if you'd like to download this drawing package and support the channel, they're available for our Patreon members and also for a one-time purchase, which you'll have permanently. So after creating our center diameter circle, let's just place it right at the origin. I'm going to call this a radius value because on our drawing it's specified as a radius value. And again, as mentioned in other tutorials, this helps us to easily visualize that we've input the correct dimension. So just create your circle, D for dimension, select your circle, right click before you place it, and then we're going to call this a radius value. Let's place it in approximately the same location as our drawing. This is going to be 0.3125. We'll go right on ahead and create another center diameter circle at the same location, place it off to the side and do the same thing. D for dimension, right click, radius, and this is going to be 0.5. Let's just clean this up, pull the dimensions off to the side so they're out of the way. Next, let's go ahead and make another circle, which will be for our piston pin. And then here we're going to make it vertically constrained to the origin. And that way it can't move left and right, just up and down. So now let's create a dimension from our two center points. And this is going to be 2.25. If you see a blue sketch feature on the screen, it just means that it's not constrained. And we can prove that again by opening up our sketch folder. And there we have it. It's still in edit mode. So let's add a dimension to our circle here. Let's call this 0.375. This is a diameter value. Let's go ahead and create another one. And this will be 0.625. And again, move your dimensions off to the side in the same position as you see it on your drawing. And that helps you to easily visualize that you've input the correct dimension. Let's create a construction line from center point to center point. I'm going to create that construction line by making sure it's selected and then pressing X. Let's just create our other lines off to the side here. Now let's make sure they're symmetric. And we pick our sketch features first and then our center line last. Now we can add a dimension to this. And as our drawing shows, it is 0.5. Next, let's separate these into two closed profiles. And I'm just going to put the line down below because I can constrain it coincidentally between the line and the center point. Some people, let me just delete this. Some people will create the line right where it should be. And remember, our mouse cursor snaps to the grid, but it doesn't necessarily mean that it's constrained. So this is kind of false. A lot of people get into this trap. They think, well, it's constrained, but it isn't. In fact, we can grab the endpoint and drag it down. And so that's why just creating the line down below and then constraining it coincidentally to the origin is an easier way of doing it. Now we're not quite done. If we look at the piston pin component, we can see that there is a 0.15 dimension through. So let's do that. Let's click right there and just add 0.15. And again, we can move this off to the side. now that our root level or our master sketch is complete, we can finish the sketch. And what should we start off with first? Well, let's go in the order of the parts list that we see on our exploded view. The first is our piston rod. So what we're going to do is go to extrude and grab the profiles that we want to extrude for our piston rod. Now I'm just going to grab these two because this upper profile is a different extrude distance. So let's just select those two profiles. We're going to go symmetric, whole length, and then our distance is going to be as on our drawing, 0.325. Perfect. Our sketch is hidden and I've made a mistake just to prove a point. We have created a body right now and it lives in the bodies folder. We don't want that. I'm going to go undo. The sketch becomes visible again. Let's go back to extrude and we're going to do the exact same thing. Whole length, distance of 0.325. But now we're going to go operation, new component. Now the way that this works is the component that we've created needs to be active, because when I go OK, you can see that within this subassembly now lives component 13.1, and we're going to quickly rename this our piston rod. Next, let's go back to that sketch. Let's make it visible again. And now to add the body to the piston rod, I'm going to make this piston rod active. And you can see that Fusion is having a little difficult time. The dialog window is flashing. So in order to make this easier on yourself, you can just right click and go activate. You can see that the sketch is still visible. We can still work with it. And what we're going to do is we're going to extrude that closed profile now. And we can go back to symmetry, whole length, and this overall distance is going to be 0.4. Now the operation defaults to join, and because our piston rod is active, this will be joined to the piston rod component. So let's go join. Now let's expand piston rod and we can see that there's one body right there. Excellent. Let's finish the piston rod now that it's active. I'm just going to hide that root level sketch. And now we can solely work with the piston rod. So let's create another sketch on this face and finish this pocket. So I'm going to create a 2-point rectangle. Make sure it's a center rectangle. I'm just going to place it at the center here. And it doesn't really matter how big it is right now. We're going to constrain it into place. Let's add a vertical constraint to the center point and to our origin. Now, believe it or not, this line is tangent to this arc. And even though they're not touching, we can still make them tangent to each other. So tangent, there we go. And we can prove it on our drawing. This dimension is 0.5. So let's just create a referenced dimension or a driven dimension. And there we have it, 0.5. So that's spot on. Now let's do the same thing up at the top. I'm going to go to a coincident constraint and make that coincident to this arc. Now, because this is constrained right to the origin, if I move this back and forth, you can see that everything is symmetric. No worries. We don't have to add a symmetry constraint to that. D for dimension. Let's create it right here. 0.3. And everything is locked in. Finish that sketch. And now let's go to our extrude. We can grab that profile, move it on in, minus 0.1. Okay. Now we don't have to do this to both sides. We're simply going to mirror it to the other side. But what I'd like to do before mirroring it is go to our fillet tool and add our fillets. So let's do that on each of the inside corners. And this value is 0.05. Perfect. So the piston rod is almost done. We just need to mirror it to the other side. Let's go to create and mirror. And then here with our object type, think of features as everything we see in our timeline. So what do we want to mirror? Well, we want to mirror the extrude, which we just created, and our fillet. There we have it. Let's select our mirror plane, X, Z, and now it mirrors all that geometry to the other side. Compute type, let's leave it as identical. And there we have it. This part is now complete. So we can minimize the piston rod component and go back to our root level sketch. There we have, actually I just realized that we forgot to add the hole. So let's go back to our piston rod, make sure that's active. We can hide that sketch so we don't accidentally create some relationships to it. And now let's create a sketch down here. If we look at the bottom of our piston rod, I could create a sketch on this face, I could create it on this face, or I can create it on the XY plane. What's the benefit of selecting either one of those features? Well, if I create the sketch on this face, I'll need to project this other face. And then let me just show that to you. I'm going to create it right there. Again, if I hide the body, you can see that this sketch profile is included. The other one isn't. So I'd have to go to the bodies, press P, make this geometry projected onto the plane. And so you can see what that looks like. This one's kind of fairly hidden. This one is projected. It's a little bit easier to see. I don't really like that method, to tell you the truth. So I'm going to undo, start that sketch again from scratch. And what I'm going to do is create it, in this case, on the XY plane, because those two faces are perfectly coplanar to that plane. So at this point, I'm going to go P for project, select this face, select that face, and go OK. Remember, if you ever forget a command, what the shortcut key is, don't worry. Just remember the one shortcut key, which is S. And there we can just type project, and you can find the exact same key along with other tools or features that you can use. So there we go. We've projected both of those faces. Now if I hide the body, you can see that these two faces and that geometry we can now work with. So let's go to a center diameter circle. Remember the shortcut key for this? C. Let's just press C, get into good habits with that. I'm going to create it at this midpoint right there. And as you can see, because I'm snapping to that midpoint, the constraint automatically shows up. Let's just do that on this side for fun. This is again a radius value. So click first, D for dimension, click on our circle, right click, radius, and this is going to be 125. Now let's just do the exact same thing, C for circle. I'm just going to place it off into space. Look at how easy this is. Midpoint, grab our circle, grab the line, and it will do the exact same thing. Don't worry too much about constraints. They're very easy once you get used to them. Now let's make those two circles equal so we don't have a bunch of dimensions on our screen, and we're good to go. Finish sketch. Let's make the body visible again. And now what we can do is extrude 1, 2, 3, 4. Actually, before we proceed, let's just teach you a new skill. Instead of selecting 4 closed profiles, what I could do is go back to that sketch. Let's edit it. I'm just going to hide the body to make this a little easier to see. If I turn this closed profile into construction geometry, so double select it and press X, now this is 1 closed profile instead of 2. So look at the difference. This circle on the left has 2 closed profiles, but again, if I double click this chain and then press X, it turns into 1 closed profile. That's a whole lot easier to work with. Let's go finish sketch, make the body visible again, and now I can simply extrude this entire profile. And let's go up. This is going to be 0.25, and we're going to join. Again, make sure piston rod is currently active. Now let's make this sketch visible again because we have to put the tapped holes in there. Let's go to hole, select the center points, go over to tapped hole type, and make sure unified screw threads is selected. And the screw size here is a number 6. So number 632, let's leave it at 2B. The difference in class here between 2B and 3B, 3B has a little tighter tolerance. So we don't need to worry about that. Let's just keep it at 2B. And the distance. We don't want this to have a distance attached to it. That affects what we see on our drawing. We just want to say we want this to go all the way through. If you're working in metric, instead of the 632 imperial thread, just go and select the thread type as metric, and then select for the size 3.5 millimeters by 0.6. That's almost the exact same size. So let's just go back here to unified and make sure that we have a number 6 by 32 2B. Now one thing you'll notice that sometimes when you adjust something in the hole tool, the depth of the thread will automatically change. So this has gone back to 0.25 or 1/4 inch. I'm just going to pull this and then again go back here to extents and go all, and now this says all instead of a finite number of 0.25. Let's go OK, and now our piston rod is done. We can just hide the sketch, and in fact we can rename these sketches if we'd like. I'm just going to go to the master sketch and call this our master sketch. And then our other sketches within our piston rod, I'd like to rename. This is going to become our pocket sketch. And then lastly, sketch 2 is going to be our hole sketch. Perfect. Now that the piston rod is finished, we can go back to our master sketch. Let's make this visible again. And then here to make this work, again, we need to activate our piston assembly. So again, if Fusion is giving you a hard time, I can't really select that radio button. Don't worry, just right click and go activate. Now let's go to extrude, grab this closed profile. We're going to go back to symmetric, hole length, and this is going to be 0.325. And remember, instead of new body, we're going to go to new component. Let's go OK. And here we have component 14, which is supposed to be our piston rod cap. And then what we could do, we could use the geometry in the sketches and the piston rod sketches for our hole sketch. We could use that exact same geometry to create the wings on the side for those screws, or we can just create a new sketch within our piston rod cap component. So what would you do? Would you create a new sketch at this point, or do you utilize a previous made sketch? Well, in this case, it doesn't really matter. Just remember this within Fusion, that whatever you do, if you're creating a relationship, always try and track those relationships. So what I'm going to do is let's utilize that previous sketch. So all I need to do is I'm going to hide the body of the piston rod. And again, our master sketch is visible. And then I'm going to make the whole sketch visible right there. Because I'm going to add this body to our piston rod cap, make sure that piston rod cap is active. There we have it. Let's just do that and go extrude. I can grab those two profiles, which I've already created again. I can bring this on down to negative 0.25. And instead of cut, we're going to go to join. There we go. OK. Now we're not done yet, because the other side of this, in order for the screws to lay on this surface, we're going to have to cut this out. So let's go back to our sketch profile. I'm going to go back to extrude, grab those two again. And now, instead of our start being at our profile plane, which is the start of our sketch, I'm going to go to object. And I'd like to start on this face. Now when I pull the arrow down, it will just merely cut out that little section and allow for our screws to lay on that face without problem. So let's just go distance. Let's go all and see what happens. We get an error there. It's not actually cutting all the way through, so I can't use all. Let's go to distance, and let's just go to a random distance over here, 0.5, and that will cut out that profile, no problem. Now let's hide the whole sketch. Let's hide the master sketch, and we're back to the piston rod cap over here. What's missing? It's the through holes. So remember again, we've got the center points for these already, and that's in the previously made hole sketch in our piston rod. So let's just make that visible again, and we can create these holes all the way through. Now remember, the tapped holes that we've created are for a number 6. We don't actually have to put in the value that's on our drawing. The drawing says 0.15, but we don't need to remember this. When we're working with bolts and screws, all we need to do is select for our hole tap type, clearance. And then we pick the exact same size of screw. So I'm going to go to our unified screw threads. Fastener type is a socket head cap screw. And then size is number 6. And it will automatically create the correct hole size going through. Now the depth 0.25. Again, we don't want 2.5. We want to go all. And that will change it from a finite number to on our drawing, which says through. And that's the correct terminology that we'd like. Very good. This is looking great. Again, the diameter of our hole is shown here, 0.15, which meets perfectly up with what we see on our drawing. Let's go OK. So let's just be clear on one thing. I have used a master sketch to create most of the geometry of the piston rod cap, the piston pin, the piston rod, but alternatively, you can create all of those as individual sketches. You can create one component at a time, make their own sketch, but give this a try. This will give you a little practice to make sure that you're selecting the right components, you're activating them at the right time, you're creating features within them, and you're also seeing how you can actually utilize the relationships that you've created in order to create holes and other features within Fusion, which is a huge time saver, and it can boost productivity immensely. Again, these are pretty simple features, but when you get into more complex drawings, you might want to utilize the techniques that I've just shown you. Very good. Piston rod cap is done. Now the master sketch is visible. I'm going to go back to the piston assembly, make this active because I'd like to make the piston pin. So let's go over here to extrude. I'm going to grab that inside profile. Let's go to symmetric, whole length. And again, our distance here is 1 inch as shown on our drawing. So let's go there. And right now, remember that our operation needs to be new component and make sure that piston assembly is active. So we can go OK. Let's go back to component 15. We can actually hide master sketch. And I'm going to rename this our piston pin. And let's make piston pin active. And here we're just going to add chamfers to both faces. Now I could pick all the edges 1, 2, 3, 4, or I could just pick the 2 faces, 1 and 2, and it will add the chamfers to all the edges on those faces. And as we see in our drawing, these chamfers are 0.02. There we have it. So the 3 main components in our piston assembly are done. Let's make sure the piston rod cap, the body is visible. Oh, sorry, not the piston rod cap, the piston rod. Now the body is hidden. And as you can see, because the piston pin is active, the other components are semi-transparent. But as soon as we make the piston assembly active, then it makes all of them shaded. Now the problem here is that, as you can see, we can still move those components off to the side. If you ever accidentally move them, you'll see up here our position tool shows up. I could capture it, and this is a little bit annoying because it captures it in the position that I want. But let's get rid of that. How do we do it? Let's make our top level component active. Now all the way to the end of our timeline, and there it is, our capture position. I'm just going to delete that, and it puts everything back in its proper location. Now I'd like to join these together. Very easy. Let's go to assemble. Well, before we do that, let's go to our piston assembly, make sure it's active, assemble, and we're going to go as built joint. Remember this to that. I'm going to grab the rod cap and I want to assemble it to the piston rod. So this to that. And it's a rigid type. Let's go OK. Right click, 12 o'clock is repeat as built joint. It repeats the last tool used. I'm going to join the pin to the piston rod and make sure that's rigid as well. Let's go OK. And conveniently, it has placed the joint at the origin for both of those relationships. So here we can just click on the joint and go V to hide it. We can click again, V to hide it. The first joint was for the first relationship we created, and the second joint was for the second relationship we created. And both of those relationships are right here. If you expand relationships and joints, you can just hover over these, and it should tell you in Fusion didn't have this bug, which is just a little bit annoying right now, but that's okay. Just work with it. We can always right click and go edit, and it will show you the 2 components that are joined together if we just click on components. And in our browser, they are underlined as well. Great. So this is looking really good. Let's just minimize some things, clean it up a little bit. Perfect. Now what's left? Well, we've got our socket head screws, and conveniently on the drawing package, it will show the part number for these screws. So let's go right into McMaster, and we can just search for that exact part number. 91251A148. It will bring up that particular component. Let's just expand this window a little bit, and we can make sure to download this 3D step file. So let's go download. And at this point, again, because we're inserting a component into our current subassembly, we need to make sure piston assembly is active. If you have anything else active, it will insert this screw into this individual component and create a subassembly instead of utilizing the piston assembly as where the screw will be inserted. So there it is. I'm just going to move it off to the side here temporarily. Let's go okie dokie. Assemble. I'm just going to go joint. I've created a shortcut on our toolbar. Grab the underside of the screw. Just click the face first and then the center point, and then our corresponding face. Pick the face first and then the center point. There we go. It's locked in. Let's go OK. And then we can go back to assemble, duplicate with joints, the component. I'm going to grab the component in the browser, and then I'm going to select this face and the center point in order to make a brand new component. And you can see it will place it in our piston assembly. And to get rid of those two joint symbols, I can just go over to relationships, expand joints, and rigid 3 and 4 are the joints I've just created. So if I hide them, that will hide the joints on the screen. Great, let's minimize those. This is looking really good. Now, last but not least is our piston. So what I'm going to do is I'm going to create this using its own sketch. And so again, you could have done this all the way along with the piston rod, the rod cap, the piston pin, instead of creating a master sketch. So let's go over here, Piston Assembly. We're going to right click and create a new component. Let's call this our piston. Now to hide everything easily, we're just going to right click piston and go isolate. That leaves us with a blank canvas. Let's create a sketch. Create it right on the XZ construction plane. And here there's a bunch of ways of going about this. You can utilize the way that I teach or whatever other method you can think of. There's no right or wrong here. It's just one way of going about it. So I'm going to first of all create a line from the origin up, and this is going to be a center line. As our drawing shows, this is going to be 1 inch. Now I'm going to turn this line into a center line. So if you grab that in the line type, the difference between this and a construction line is what I'll show you in a moment. Let's just create a line, create the extents over here. I'm going to hover over the origin and move my line over, and that will snap it perpendicular to the origin. Great, now you can see that we've got 3 perpendicular constraints. This one by default has to be perpendicular. And in fact, if I go to the perpendicular constraint and I say I want these 2 lines perpendicular, the sketch geometry is over constrained. Mathematically, this has to be 90 degrees. Great. Because we've created a center line, look what happens when I go D for dimension, grab the center line, and then grab the outside. It will actually create a diameter for us, which is perfect because this is defined by a diameter on our drawing, 1.75. Now this is going to be the main body sketch for our piston. And that's so I'm going to create a line over here. Although this isn't going to be revolved, I can still utilize this line, which is going to be creating the interference relief or cutting out the interference relief of this piston. Let's just put in our dimensions, D for dimension. There we go. From the end point to the bottom, this is 0.25. And then our angle from this line to that line of 30 degrees. And again, mathematically, if we have 2 aspects of a triangle, for example, this is our triangle, we know 2 aspects of it, the 0.25 and the angle, well then this dimension is automatically figured out for us. So if I create a dimension from there to there, then it says, well, you've got an over-constrained sketch, crate driven. And so here we've just learned an important lesson. A lot of people will get very frustrated because they're wondering why certain dimensions will be over-constrained and others won't be. This all has to do with math. And as you continue to learn with this channel, you learn important things like that. If we have a triangle and we know 2 aspects of it, the third is automatically found out within Fusion, or we can calculate that mathematically. And so instead of getting frustrated, just keep on learning. There's so much to learn here, both mathematically with CAD design and all of this in order to make your design skills better and better. I'm just going to undo that 144 dimension. So just Command Z or Control Z if you're working on a Windows computer. Great, let's finish that sketch. Okay, just before we get to the next step, I'd like to send out a huge shout out to our sponsor, PCBWay. They've got incredible services. I'd just like to highlight one of them today. Let's go on over to PCB Design. Here you can see you can create professional electronic designs for your next project. This is amazing. You can upload your design here. You can get quotes. You can get help from professional engineering teams, end-to-end development, fast turnaround, manufacturing advantage. And note some of the turnkey electronic design services. You have PCB layout, PCB design, and mechanical and enclosure design. Some pretty amazing things over at PCBWay. Please check them out. I've been working with them for 1.5 years now and have really enjoyed it so far. Thank you, PCBWay, for your support. Hope you guys check them out. And now what I'm going to do is go revolve, and I'm going to make sure to grab both of those profiles. The axis is going to be our Z axis. And I've done something wrong here. Let's just go ahead and pick the axis. Perfect. New body, because we've already selected piston over here and we don't want to create a new component within this. This is just a body. Perfect. Let's go and expand our piston, expand the sketches. I'm going to rename sketch 1 our body sketch, and I can quickly go and extrude that profile. Let's make the body sketch visible again. Extrude this profile. Let's go symmetric. Whole length, doesn't really matter. We can go all, and that will cut all the way through. And then all we have to do here is mirror it to the other side. So let's go over to our mirror. I'm going to select this feature. Again, I can select it in the canvas, or I prefer to select it in the timeline because I know exactly what I'm picking. Mirror plane. Let's just make sure that our mirror plane is going to be this, our YZ in this instance, and it will pop it on over to the other side. Let's go identical, and there we have it. So now this is looking really good. Let's create a sketch on our bottom face, right click the face, and we can just go create sketch. Now let's create another center diameter circle, C, at our origin. We're going to move this on over, and on our drawing this says it is 1.625. Let's create some lines. These are just going to be vertical lines, there to there. And then I'm going to create one at the center again. And remember, we could snap it. Actually, this works right at the center point. I could go from there to there, and it should snap it into place. But if I didn't do that, sometimes we have to just pay real close attention. Where is it snapping to the grid, or is it creating a constraint? If it's not creating a constraint, we can just put it off to the side, make sure it's a vertical, and then create a coincident constraint from there to our origin. And here I'm going to turn this into a construction line yet again. Let's make everything symmetric. Pick our sketch objects first, and then our center line last. And now we can put in a dimension between those two, and on our drawing it says that this dimension is 1.35. Great, let's finish that sketch. And here we can go extrude, and let's go up. We just have to do a little bit of math here. This is going to be -1 plus our offset of 0.375, and go enter. I can go ahead and rename this sketch 2 to our pocket sketch. Now let's do the cutout for our piston pin. Go ahead and create a new sketch. Let's make it on our XZ construction plane. And here I want to see through it, so I'm going to select slice, and there we've sliced the body exactly where we created our sketch. Now keep in mind as we do that, that none of this geometry is usable. We're going to have to project it. P for project. Let's, instead of going selection filters, we're going to go bodies and select this entire body. Let's go OK. And now if we hide the bodies in our piston, you can see the extremity of our piston has been projected onto the sketch. And we can utilize this in order to create this cutout. So here I'm going to create a 2-point rectangle. I'm just going to space this inside of our closed profile. And I'll show you a new skill here. I'd like to make sure that this line is perfectly centered on this line. So I can just create a point, place that at our center point, and then go midpoint here. And I can just grab that single point and grab that line, and they're locked together. Now our overall length is going to be 1 inch. And the height here, we're going to set to 0.5. Perfect. Everything should be locked in. You could have created that rectangle using several other methods. Don't worry, whatever works for you. Just make sure that everything is constrained or defined. Let's go finish sketch. I'm going to now extrude this profile. And we're going to go to symmetric. We can go distance all. Now it's not actually doing anything because the body isn't visible. So make the body visible. Again, we can now grab this and go all, and it should cut that all the way out. Perfect. Our piston is looking really good here. Here's a tip with Infusion. When it comes to chamfers and fillets, if they are large, if they affect the overall geometry or shape of our part, then we create those early on. If they're just cosmetic, we save those to the absolute very end. As we look at our cutout over here, we can see that it's got some pretty big fillets. And for that reason, we're going to create them right now. So let's go up to our fillet tool. And first of all, I'm going to grab these 4 edges. And remember, we can look right through our part. Sometimes it's easy to find an edge, sometimes it isn't. So I'm just going to orbit and select our edge. I've had many comment recently, how is it that I move and orbit and pan and all of this easily? Well, again, I use a 3D Connection Space Mouse. If you're interested, a link is in the description below. So this particular fillet is 0.3. Let's create a new selection set and grab our 4 edges down here, and these are defined as 0.15 radius. There we have it. This is looking really good. Let's just make sure to save our project at this point. Let's create the bosses now for our piston pin. I'm going to select the underside of our piston and go create sketch. And if we look closely, these 2 bosses here are exactly the same. So instead of sketching both of them, I'm just going to sketch one and eventually mirror it to the other side. So let's go to our rectangle, center point rectangle, just create it off into space here. Remember again, this is not linked to anything or constrained. So I'm going to go to the vertical constraint, select the center point and the origin. And now again, this can't move left and right, just up and down. And here I can put in my other constraints. The overall width here is 0.625. The overall height of it is 0.25. And then here, the math between this and the origin is 0.4 divided by 2. Now I could create a center line in this instance and make sure that the value is accurate and defined as 0.4. However, in this instance, I'm just going to go 0.4 divided by 2, and that will fully define it as well. The reason I don't often like to do that, as I've explained many times before, is I like to see exactly what's on the drawing inputted in my sketch. And that way there's no second guessing. These are easy dimensions, everyone, but as soon as we get to really complicated dimensions, then doing the math ourselves, well, we're prone to human error. So the less chance of that happening, the better. But this is fully defined now, so let's go finish sketch. And I'm going to go extrude. Now here's a really cool tip in Fusion. We can see if I pull this down, I don't actually know how long this is supposed to be. I could do the math for this, but here's the trick. It is 1.125 from the top face. So instead of doing the math, I'm going to go to our kebab menu over here and go to re-anchor. I'm going to grab the top face, and here it automatically defines it now from starting from this profile plane. So I'm going to change this from 1.375 to 1.125, and now I haven't done any math. I've just redefined the start plane, even though I've created the sketch on an entirely different plane. Perfect. Let's create the through hole. I'm going to create a sketch right on that boss there. Create sketch, create a single point. And I'm going to create it right on our Z axis. So there we go. I'm going to fully define this. Vertical to our origin, D for dimension. From there to there is 0.3. And the reason why I'm not going to do an extrude here is I'd like the drawing to say through. And the way to do that is to use the hole tool. So let's just go finish sketch. I'm going to go right away to the hole tool, select that point. And here again, I'm going to pick hole tap type as normal or simple. And then we're going to pick the diameter, which is 0.375. And then distance is going to go all. So again, this all specification will say through on our drawing. Let's go OK. Let's put in our fillets now. I'm going to do the big fillets first, which are 0.25. And then I'm going to go right click, repeat fillet, and I'm going to put in all of the small fillets. So let's just go around here. Again, you can look through your individual bodies. If you can't select through, it's because your selection filter doesn't have select through on it. So I'm going to pick those, and on these two chains as well, and then specify the value as 0.05. So this is looking really, really good. Next, I could rename all these sketches, no problem. I'm going to go to create though, go to mirror, features. Let's pick all the features that just relate to this boss in our timeline. So it's the one extrude, the hole, and the two fillets. Mirror plane is going to be right on our, in this instance, our YZ plane. And we can make this identical as well. So this is looking really, really good. What's left? Well, our grooves. So let's create another sketch. I'm going to create it on our XZ construction plane. Again, I can go slice all the way through. P for project. Let's project this entire body. Can hide the body right now, and we've got the outline, all the extremities of our piston body. So here, let's zoom on in. We're going to make this really easy on ourselves. I'm just going to create one groove profile. And I'll show you in a moment why that's a whole lot better than sketching all of the groove profiles. So D for dimension. And on our drawing, we see detail E. This value is 0.04. The depth of our groove, this is 0.025. The overall width of it is also 0.04. And now we've got a fully defined groove. Let's go finish sketch. And now make the body visible again. I can simply go to revolve, grab that closed profile. The axis, we can pick any of our cylindrical bodies, or we can pick the axis itself here, which is our Z axis. So let's just pick the outside diameter. It will cut all the way through. Let's go OK. And now let's pick a rectangular pattern. Remember, rectangular pattern refers to the direction that we want a feature to go, not to the feature itself. The feature itself is a round feature. So we don't want to pick a circular pattern. In this case, we just want to go down in one axis, our Z axis. And so rectangular pattern is the way to go. Object type, features, I'm going to pick that revolve. And our axis again, I'm just going to pick that Z axis. And here we can go down, and it's automatically defaults to 3 quantity. But we want the distribution, instead of being the extent, so from the top to the bottom, we want to go to spacing, which is what we can easily figure out on our drawing. So the distance here is minus 0.025 minus 0.04. Great. Let's go OK. If we created those grooves using sketch features alone, we would have had to have selected each of those individually to revolve around, which is no problem. But remember, if we have 100 different grooves running up and down this, or many more, then think of individually selecting every single one of those closed profiles would take forever. So let's just add more if we want. And look at how easy it is within Fusion. We could just type, 50 if we wanted. And there it adds all of it. Now I've made a mistake here. I've accidentally selected the distance. I'm just going to go cancel and it should reset that all. But that's the benefit of using patterns when we can. Whenever there's a pattern, let's try and utilize it within Fusion. Let's just go ahead and save our design file again. Now that we've got all of our components created, we just need to assemble our piston to our piston assembly. So let's right click and make it active. Let's right click and isolate the piston assembly. That will make all of those other components visible. I'm going to move the piston off to the side. Let's go to join. And here the snap point. I want the snap point to be the center between this face and the other face. Well, I can't really do that just with the standard option. So I have to go over to select between 2 faces. And I can just pick the outer faces if I want. The snap point can be any point of our cylinder. So any of the edges, we can pick the center point as well. And there we can hold down Command, but you can see that the joint location will be right at the center of those 2 bosses. So I'm just going to again select this circle, and then the other component, component 2, is going to be our pin. I'm going to hover over that, hold down Command on Mac, Control on Windows, and select the triangle. There's the triangle. It's the dead center of this component. Perfect. It will lock those in together. Let's put some motion on here because this shouldn't be rigid, but it should be revolute. Very good. This is spinning all the way around. We don't want it to have an unlimited motion. This has motion limits. So we're going to put a minimum and a maximum on there. Let's just grab these flags. I'm going to move the one off to the side, and let's just see when this hits. And let's see, minus 55. That's right around that. So I'm just going to change this to minus 54. Perfect. The other side will be exactly the same, but in the positive direction. And then I can also preview limits and make sure that nothing is hitting with our piston and our piston rod. Perfect. Let's go OK. Now just let's hide that joint. So click it and press V. And at this point, let's just go to our piston, right click, physical material, and drag and drop our aluminum right onto it. So before we get to assembling all of this and creating a motion study, I just wanted to send a huge shout out to all of our Patreon and YouTube members. Thank you all so much for your support. And if you're interested in helping our channel, please consider becoming a member. You get a ton of goodies on our Patreon site, including additional tutorials, resources, practice drawings, group chats to ask for help, all sorts of goodies. If you're benefiting from this tutorial, please consider liking and hitting the hype button if available. And if you love us, please consider subscribing and hitting that notification bell, which helps our channel immensely too. Now let's save this again and move on to one of the most exciting features of this tutorial, which is going to be assembling everything and creating a motion study. So let's make our other components visible, and we can make our top level component active, and let's go unisolate all. So this is showing everything that we've created so far. Now, what do I not want to see? Well, I probably don't want to see the oil pan at this point, so I'm going to hide that. And I don't really need to see these bearings as well. So let's just hide those as well. Now we've got our piston assembly and it's floating off into space. So let's just grab that and move it off to the side. Now we can use, under assemble, we can use joints and we can use constrained components. I'm going to focus on joints right now, but I'd like to encourage all of you, try assembling all of this using joints, and then try it again using constrained components and see which one you like more. Just so all of you know, I've actually recorded this tutorial 3 or 4 times already, and I've had to delete the first 3 because I've run into some problems with using constrained components. Sometimes it's worked flawlessly, and then another time Fusion brought up a bunch of errors and I could not make it right. So I don't know if that's a bug or what it is, but just to give you all encouragement, if at first you don't succeed, just keep on trying. But what I'm going to do is show you how to assemble all of this just using joints. So let's create a joint, and you can see the shortcut there is J. Here, the snap point, we're going to pick the center of this bore. So hover over the cylinder, hold down Command, and pick the triangle. Now we're going to go over here to the journal and do the exact same thing. I'm going to hover over the cylinder and I'm going to pick the center point. Now the problem here is that the piston assembly is not centered on this journal. There's actually going to be 2 of them, but don't worry about that. We're going to go over to motion and pick the correct motion type. So instead of revolute, we're going to pick cylindrical. And as you can see, as I hover over it, it rotates and slides a component on a single axis. So let's pick that. And you can see it is sliding along that journal and also rotating along it. Now it's going to an extreme degree just to show you that motion. I can always go to the motion here and go preview, and you can see that it's spinning along that journal. It's revolving around it, but I can also go to the slide motion and do the same thing and preview it. So in real life, this does have a little bit of sliding motion, and the thing that locks it into place is the piston and the cylinder bore. So that's what we want. If the component locks perfectly in a specific position, then we can utilize more of a rigid joint or another type of joint, but this allows for a little bit of flexibility or tolerance. Let's go OK. So now it's positioned perfectly right there. I'm going to create another joint, and I'm going to snap the center of our piston now. So again, hover over our piston, hold down Command on Mac or Control on Windows, and pick the triangle. It's the center point. And I'm going to do the same thing with our cylinder bore. So hover over the bore, Command, and pick the triangle. Now, this will bring up an alarm. Our piston, as you can see, is revolving and going along that axis, which we don't want. We want to change the motion to simply a slider. So this is going to move up and down. I'd like to put some minimum and maximum limits to it. And the reason for that is that sometimes when you're whipping around the crank shaft, the piston might actually flip onto the other side because it doesn't know it has a motion limit to it. So I'd like to create motion limits so that it doesn't do that. It keeps it locked in the cylinder bore. So again, once I click both of those, I can just grab those 2 flags, and I'll just move this on up maybe 0.5 in the one direction, and I'm going to go down to maybe 1.5 in the other direction. Let's go to preview limits, and you can see, yep, now this is looking great. I'm going to go OK, And let's see if that joint was created correctly. Yes, there's no issues down here. So let's hide our engine block at this point and move our crankshaft. And you can see now we've got this correct motion with our piston assembly. Let's go back to revert position. At this point, let's just do one more piston assembly together, and then I'm going to fast forward through the other 6 and let you do the same thing. This is a fun exercise in creating all these joints and the correct motion. So make sure that our top level component is active. Let's right click, copy our piston assembly, right click our top level component, go paste, and now we can move this off to the side just like that. So let's do the same thing. We're going to go joint, pick the center of this bore, make sure to pick the triangle. And again, you can do that holding down Command or Control on Windows. And our snap point, let's go to the exact same center point of this journal here. Motion, make sure this goes to cylindrical and go OK. Now we can always hide piston assembly 1. Let's make our engine block visible again and do the same thing. Joint the center of our piston to the triangle and then to the bore. Do the same thing. Perfect motion. And we want slider. Make sure to go minimum and maximum. The minimum again is going to go minus 0.5, the maximum 1.5, and go OK. Let's just test it once again. Hide the engine block. Make the piston assembly 1 visible. And then grab our crank shaft and we can just start spinning it. So this is looking great. Now let's just go ahead. I'm going to fast forward through this and do all of the rest of these. I'll let you do the same, and then I'll see you in a moment. So there we have it. We have jointed all of our components together. We've assembled them all together, and we've got this really cool working assembly right now, working engine. Let's just make our engine block and our oil pan visible. And here you can see it is all working. Now look at all the joints on the screen. They are all visible. Very easy solution. Let's just go revert, go to select, selection filters, turn off select all, and then just select joints. Here I can window select everything, press V to hide all of those joints in one go. Now let's just go back to our crankshaft assembly. We'll make the bearings visible again. So this is almost done. We've saved the best for the last here. Let's now create a motion study. We have to find the joint that creates the original motion between the crankshaft and the bearings, or whatever moves the crankshaft. Here in the crankshaft assembly, expand relationships, and if we've done this right following this tutorial, there is our joint, crankshaft to crankshaft bearings. That's what we want to use for our motion study. So let's go to assemble. Let's create a motion study. I'm going to make this motion study a little bit bigger, bring the model down off to the side, and in fact I can hide the engine block. Let's just see the internal components. How does the motion study work? Basically, we've got time going from left to right, and this is defined as steps. And then we have the angle or the motion going up and down. So let me prove it to you. It says here, select joints to animate. I'm just going to pick the crankshaft to crankshaft bearings. And here the start is at some odd value, minus 19 degrees. And the end, it will continue at that motion all the way to the end of 100 steps, but we want to go all the way to the very end and click. And here the angle, let's just go plus 360 degrees, which is a full revolution. Make sure it says step of 100. And then we can go here to loop playback and bring our speed all the way down to 0, and let's press play and see what happens. So there we have our motion, and I can just go OK. That will save the motion study. Let's minimize all of our folders right now. We can make the engine block visible again. Let's go to our home view. Let's save it. And before we finish up, we can just go back to that motion study and right-click Edit. And here we can play it. Just go back to our play loop, back all the way down to minimum speed, and we can press play. I'm just going to move the motion study window off to the side, and there we have it. Thanks for learning with the Learn It channel. Can't wait to see you at the next tutorial.